Hello, this is Miss Nichols, and this video is about building circuits. What are the parts that you have to have in every circuit, and how could you draw them in a way that other scientists would understand? So every circuit has three critical parts and one sort of optional part. The first thing that every circuit needs is an energy source, because otherwise there's no electrical energy in the circuit. The second thing that every circuit should have is what's called a resistor or a load. That is the thing that is transforming the electrical potential energy into some other kind of energy. So that's the purpose of the circuit. Every circuit needs to have some conducting wire that connects things, and most circuits are going to have a switch because you're going to want to have the ability to turn them on or off. So the first thing to include in every circuit is your energy source. This is the thing that is going to give the electrical energy to the electrons or stores it up in those electrons. Some examples of common energy sources are batteries, sometimes called cells, capacitor, if you've heard of that. Wall outlet, of course, is an example of an energy source. Solar panels could be energy sources. There's lots of things that you can put into your circuit as a source of energy. So we are going to be including all of these elements in something called a circuit diagram. A circuit diagram is a simplified way of showing all of the electrical connections and devices in a circuit. So obviously we don't want to have to be drawing the actual battery or drawing the solar panel. We want to have a way to show a symbol for a battery or a symbol for a solar panel in a circuit that everyone will recognize. So power sources in circuits are generally represented by two parallel lines, one of which is longer than the other, with wires kind of coming out the top and the bottom. And it's not always marked, but the longer line ends up being the positive side of the battery, which is like the side of the little knobby end, so just for your reference. The second thing in every circuit is going to be whatever element in the circuit is transforming the electrical energy into another kind of energy. So for example, that toaster, a light bulb could be a resistor, a common one that we use in circuits, electric motors, a buzzer. Sometimes we have these things called that are just plain old resistors. Maybe you've seen those if you looked at circuit boards before. The function of those is just to essentially waste energy. They take the electrical energy going through and they turn it into heat. And they do that so that other resistors in the circuit get the correct amount of energy and not too much. When you draw circuit diagrams, resistors are represented by just a little squiggly line inside of the wire. So instead of trying to draw out the toaster, you're just gonna, as you're drawing your wire, you're gonna make a little squiggle line. That will be your resistor or your load. So I've been talking a little bit about it, but I should be clear that every circuit also needs to have wire in it. The purpose of the wire is basically to connect the energy source to the resistor and then connect the resistor back to the other side of the battery. So you need that wire to make that complete circuit. Doesn't matter how long the wire is. We'll see some examples of that as we practice with this material. Some examples are wire, of course, which is made out of metal. But of course, other conducting objects could act as wire as well. A human could, if you were in bad positions, or you could use water to act as a wire if it has some salt dissolved in it. So there you go. Those are things that could be wire in your circuit. In the circuit diagram, wire is just drawn with a plain straight line that connects things. And then the optional device in circuits is a switch or a button. And these are used to open or disconnect a wire, or close, which means connect. So it's kind of like a door, except that open means the electrons can't go through, right? Because there's a gap, and closed means that they can. Switches and buttons can be used to complete the circuit, or they can be used to just turn certain parts of the circuit on or off, which is really convenient. So any of these things that you've seen in your house or on any of your devices act as the switch. When you are drawing a switch in a circuit diagram, you draw it just like a door pretty much. And you can see that that is an open switch because it's disconnected. You could also draw it down, and that would be the switch in the closed position. So you can take all of these ideas and elements and combine them to make a complete circuit diagram. So if we had this really basic circuit with a battery and a switch and a light bulb and some wire in it, right, this is what it looks like in the real world. this would be the circuit diagram for the same situation, right? I've got my battery there on the left, I've got my switch on top, and I've got my light bulb on the right. It doesn't really matter what order you put these things in, because the circuit diagram is just designed to show the overall functionality of the circuit. So a quick note about what is going on inside of a circuit at the kind of level of the atoms. This is also a preview of the next video where we're going to talk more about the variables that matter in circuits. So to start, electrons exist in every atom in the wire or the battery and the resistor. There's like a chandelier there, that's the resistor. Because every element has atoms and every atom has electrons. So the electrons are already there. Electricity does not mean we're creating electrons. All of the electrons already exist. What's happening in the circuit is those electrons are loaded up with energy at the battery. So they're kind of like little trucks that carry energy, and they leave the battery with their energy, and they move through the circuit and transfer the energy from the battery to the resistor or load. So they're going to carry their energy over to that little light bulb, to the chandelier, and they're going to deposit the energy there, and then they're going to continue going through the circuit over and over and over again. So the power source that we learned about in this video, its function is to energize those electrons by pumping them in one direction, right? By piling up those electrons on the wire on one side, we are giving each one of those electrons more electrical energy because we're forcing them closer to other electrons, which is where they don't really want to be. So those piled up electrons have a lot of energy, and the spread out electrons on the other side don't have a lot of energy. Incidentally, batteries, if you look at a battery, you'll see a number written on there that says how many volts the battery is. This is kind of characteristic of the battery, and it's going to tell you how strong that battery is as a pump, how much it can force those electrons to go closer to each other. That's what the voltage value tells you, and you're going to get more about that later on. If the switch is open, right, then those electrons just stay where they are. They're piled up on one side and spread on the other. But when you close the switch, you then allow the electrons to find a path to get back to the other side of the battery, which is where they want to be, because that's where all the extra protons are. So that's what happens at a switch. The resistor, of course, is the place where the electrical energy gets transformed into other kinds of outputs. And the processes by which that happens are kind of complicated. I can explain a few of them, but some of them are beyond sort of the scope of this class. But the big idea is EE gets turned into light or heat or sound or whatever it is that your resistor is doing. And the last note is that electrons, by definition, have to use up all of their electrical energy before they return to the battery to start the cycle again. So this is like conservation of energy. We get a certain amount of energy at the battery. All of that energy has to be used up before the electrons return to the battery and do it all again. All right, let's take a minute to revisit the essential question, which is what are the critical parts of a circuit and how do I represent them in a drawing? So hopefully now you can answer that. Thanks for watching.